Welcome back, folks. In 6.2, we're talking about properties of parallelograms. 6.1 was about polygons in general. In section 6.2 here, we're going to look at a specific type of polygon, a parallelogram. Okay, objective is to use relationships among the sides, angles, and diagonals of parallelograms. Okay, so we'll give you different theorems about those different parts. All right, so first off though, what is a parallelogram? I'm going to say a parallelogram is a quadrilateral, so four-sided polygon, with both pairs of opposite sides parallel. Okay, so quadrilateral with the top and bottom parallel to each other. Okay, remember we can show that by having a single arrow on top and bottom. And then also left and right sides parallel with the two arrows. Okay, so quadrilateral four-sided shape with both sets of opposite sides parallel. And the definition of a parallelogram is going to lead to four different theorems or four different properties of parallelograms. Okay, we'll go through each of those here. Theorem 6.3, we're going to say that if a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, so if we have a parallelogram, opposite sides here will be congruent. So left and right side congruent, top and bottom sides congruent. We also have, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, so again, if we have a parallelogram, then consecutive angles, so the angles next to each other, so for example, A and B will add to 180, will be supplementary. Same thing with B and C, they'll be supplementary. C and D will be supplementary as well, and then also A and D will be supplementary. We also have, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So as in angle A and C across from each other will be congruent. Same thing with angles B and D. And then finally we have, again, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, so as in the diagonals cross each other at both's midpoint. Okay, so E would be the midpoint for both these diagonals, meaning that AE and EC will be congruent to each other. And then also BE and ED will be congruent. These two diagonals split each other into two congruent parts. So those are going to be our four theorems or four properties of parallelograms. Okay, we're not going to prove those here, but the proofs would come from properties of parallel lines and transversals or congruent triangles. Let's review them here quick again. Okay, parallelograms have opposite sides that are congruent, consecutive angles that are supplementary, opposite angles that are congruent, and diagonals that bisect each other, split each other into two equal parts. So let's take a look at using those properties. In problem 1, we're finding some angles. Part A asks, what is the measure of angle 1 and angle 2 in the parallelogram? So we have a parallelogram. We're given 75 degrees here, and we want to find angles 1 and 2. Okay, we'll start off with the measure of angle 1. Okay, since the 75 we're given and 1 are consecutive angles, angles next to each other, our theorem said they'll be supplementary. So for angle 1 I can do is I can go 180 minus 75, okay, because they'll add to 180, which gives me a 105 degrees. Okay, so again, consecutive angles are supplementary. For angle 2, notice that the 75 were given and the 2 are opposite angles. Theorems we just gave you said that opposite angles are congruent, therefore angle 2 is just 75 degrees. Okay, or I suppose we know that 2 and 1 are supplementary because they're consecutive. You could find it also that way. Okay, but anyways, here's our two sets of properties of angles for parallelograms. Consecutive angles supplementary, opposite angles congruent. Okay, once you hit pause on the video, give part B a shot, and then hit play to check your answers. All right, part 1C, we'll go through this together. Okay, it's the same idea, but we have an extra diagonal running through this parallelogram. Okay, again, we want to find the measure of angles 1, 2, and 3. We can start off with measure of angle 1. Since 1 is across from this 113 degrees we're given, we know there'll be opposite angles again, so congruent. Okay, for angle 2 then, notice once I have my 1 is 113 degrees. Let's go through part C together. Okay, same idea, but with this parallelogram we have an extra diagonal running through it, giving us a few more angles to find. Same idea though, find the measure of angles 1, 2, and 3 in the parallelogram. We can start off with a measure of angle 1. Since 1 is opposite to this 113, I know that's going to be congruent to it as well. Okay, so 1 will be 113. Then as far as finding angles 2 and 3, easiest way to do that is going to be to recognize that this parallelogram split into two triangles, two congruent triangles. Okay, and since I know two of the angles of those triangles, 113 and 22, I can subtract those from 180. To end up with the 45 for angle 2. All right, same idea for angle 3. We could say that measure of angle 3 is equal to 180 minus 113 minus 45, which will give us a 22 degrees. So angle 3 is 22 degrees. And then the thing to notice here, and the other way we can approach this problem, is that 3 is congruent to this 22 we're given here. Okay, reason for that is, with the parallelogram, my opposite sides are parallel. So what I have here then are parallel lines with a transversal. We know that when lines are parallel, alternate interior angles are congruent. Therefore, these two angles have to both be 22. Same idea with the angle 2 and the other 45. Again, we have parallel lines on the left and right side with the transversal. Again, alternate interior angles are congruent. Okay, so a couple different ways, a couple different theorems we can look at for that problem. In problem 2, we're going to bring some algebra into the mix and use our properties to solve for variables in parallelograms. So 2a says solve for x and y in the parallelogram. And it looks like x and y are part of expressions for the side lengths of my parallelogram here. We know that the sides of parallelograms, or the opposite sides, are congruent. Therefore, I can set up that 3x minus 5 is equal to 2x plus 1. Okay, then I'm going to need a second equation for my y. Again, since the opposite sides are congruent, the left and right sides will be congruent as well. So we can say that x plus 2 is equal to y. Okay, with this problem, I need to start with my left equation because it has only x's in it, so we can solve for x. The right equation with an x and a y, we can't solve for anything right off the bat. Okay, so simple system of equations. We want to solve the equation with a single variable in it. On the left, I'll subtract 2x from both sides of the equation. That's going to leave me with x minus 5 is equal to 1. Okay, we'll add 5 to both sides, which gives us x is equal to 6. Okay, so there's half our answer. What we'll do then is we'll substitute that 6 in for the x here, which will leave us with a 6 plus 2 is equal to y, or in other words, y is equal to 8. All right, so there's my x and y from this parallelogram. Again, part B is the same idea. Pause the video, work through that one. There's a couple different ways you can set up equations for that, and then hit play to check your answer. Last thing we're going to look at quick is an extension of our properties of parallelograms. Okay, theorem 6.7 says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so if I have 1, 2, 3 or more parallel lines, and a transversal that goes through it is cut into 2 congruent parts or more congruent parts, okay, that means that my other transversal will be cut into congruent parts as well. In other words, these lines are spaced equally and they're going to cut all the lines up equally. Let's take a look at how that theorem works in problem 3. Part A says, in the figure, line AE is parallel to line BF, which is parallel to line CG, which is parallel to line DH. So I have a set of 1, 2, 3, 4 parallel lines. We're also given that AB is equal to BC, which is equal to CD. So I have 3 congruent segments. And EF is equal to 2.25. Okay, we want to know what is EH. So what's the length from E to H? Okay, well, my theorem applies here since my 4 parallel lines cut congruent segments on one transversal. It'll cut congruent segments on every transversal, meaning that here I'll just have another 2.25 and a 2.25 again. Therefore, EH, or the length from E to H, is 2.25 plus 2.25 plus 2.25. In other words, 6.75 units. All right, again, part B, same idea. Hit pause, work through that solution, and then hit play to check your answer out.